Today we see the concept of the changes in the standard Ethernet or a standard. So the 10 Mbps standard Ethernet has a gone through the several changes before moving to the higher data rate, and these changes actually open the road to the evolution of the Ethernet to become the compatible with the other higher data rate plans. So today we see the discuss the topic of bridge Ethernet, switch Ethernet, full duplex Ethernet. Now network with any without bridge. Okay, so a bridge divide the network into the two or more network. Bridge divide the network into the two or more network. Bandwidth wise, each network is a independent. For example, you can be see in the figure a network with a 12 station is divided into the two network, each with a 6 station. Now each network has a capacity of a 10 Mbps. The 10 Mbps capacity is each segment is now shared between the 6 station, not a 12 station. In a network with a heavy load, each station theoretically is offered the 10 by 6 Mbps instead of the 10 by 12 Mbps, assuming that the traffic is not going through the bridge. Now it is obvious that if we further divide the network, we can gain more bandwidth of the each segment. For example, if we use the 4 port bridge, each station now offer the 10 by 3 Mbps, which is the 4 times more than the unbridged network. Second, here we see the concept of the separating collision domain. The collision domain figure name is a collision domain in and the unbridged network and the bridge network. So another advantages of the bridge is the separation of the collision domain. Figure shows the collision domain for a unbridged and the bridge network. You can see that the collision domain become much smaller and the probability of the collision is reduced tremendously. Without the bridging, 12 station content for access to the medium, and with bridge only 3 station content for the access to the medium. So this is the concept of the separating collision domain. Next we see the concept of the switch Ethernet. The idea of a bridge LAN can be extended to the switch LAN instead of having the 2-4 network. Why not have a N network where the N is the number of a station on the LAN? In the other word, if we can have a multiple port bridge, why not have a N port bridge or a switch? So in this way, the bandwidth is a share only between the station and the switch and the switch 5 Mbps per each. Okay, so in addition, the collision domain is divided into the N domain. So a layer to switch in an N-port bridge with additional sophistication that allows the faster handling of the packet and the evolution of the bridge Ethernet, so that Ethernet was a big step of the open to way the even faster Ethernet. Okay, so this is the concept of the switch Ethernet. Next we see the full duplex Ethernet. So one of the limitation of a 10 base 5 and the 10 base 2, that communication is a half duplex. So a station can either send or receive because the communication is a half duplex, but may not do both at the same time. So the next step is the evolution was to move the switch Ethernet to full duplex switch Ethernet. So if it is a full duplex switch Ethernet, so station can send or receive can be send the receive at the same time. The full duplex mode increase the capacity of each domain from the 10 to 20 Mbps. Figure shows the switch Ethernet in the full duplex mode. Note that instead of using one link between the station and the switch, the configuration used the two link, one to transmit and one for the receive. This is the concept of the full duplex switch Ethernet. Thank you so much.